Last time we have prepared the steel tool head for the ATC turret. Today is the day. Things are going to get really serious and the chips are going to fly. Electrical components are going to get really hot. And trust me, the ATC is going to come to life today. Last time I disassembled finally the temporary tool holder. But let's start it off with something easier, yet essential. This is the tool holding wedge. I designed it using ZW3D, making sure everything is going to fit and work, assuming that it will look like on the drawing. Okay, enough of theory. Now this looks almost like it, just not wedgy enough. Now let's take it to dimensions. Good enough. Now drilling. Some chamfers won't hurt. No chamfers, the opposite. Counter boring for the screw heads. Recently I made this angle block. It is going to help me with the angled surface of the wedge. Seems like it. Now the tapped holes in between. These will help me to get the tool out of the slot. Now the last thing which is left is the relief, the second angled surface. It can be done by hand, roughly on the belt grinder. Recently I'm a big fan of cold bluing. And it's finished. Actually I made 8 of them. Let's check if the fit is right. Yup, it seems about right. I've got some screws to mount the ATC on the lathe, finally. I can't resist. Let's take a quick test ride. Wow, I think we are on the right track. And I think I will have to prepare some covers. The chips will be flying everywhere. To avoid damage and keep it clean, I designed some bent covers made of steel metal sheet. Speaking of steel covers, today's video is sponsored by Xtool with their Xtool Metal Fab. Xtool Metal Fab is a 3-in-1 laser welding, cutting and cleaning device. It can be upgraded to a precise CNC laser cutter and an engraver. Laser welding is currently one of the fastest growing welding technologies. It is becoming increasingly common across the metalworking industry, but it also seems it is getting recently more and more affordable also for hobbyists and other crazy DIYers like me and you. Laser welding is fast. It produces neat weld beads that often require less grinding afterwards. It also introduces less heat into the material, which means less distortion, especially on thin sheet metal. And apparently it's easier to learn than TIG or even MIG welding, though I can't confirm that one yet. Having a device like this at home, especially the upgraded version with the CNC table, would be really handy for making, for example, covers for my machine. And then maybe owning a press brake. Sky's the limit. But getting back to reality, the Axle Metal Fab is right now on sale and it can be bought for roughly $3,899 for the 800 watt version. Being honest, I'm really keeping an eye how the laser cutting and welding technology goes along recently. The prices for these are getting dangerously close to a point where it gets more affordable even for mad garage warriors. Having such all-in-one powerhouse at home seems quite convenient, especially considering they claim it can cut carbon steel up to 10mm thickness with the 1200 watt version and 8mm with the 800 watt version. Now that's pretty impressive, isn't it? Thanks to Xtol for sponsoring this video. If you are interested in such laser combo everything doing device, check details in the description. By the way, there is also a discount for my viewers. And now let's get back to our ATC turret. We are getting close dangerously fast to the climax of this show. In order to prepare for round tools, I designed these custom tool holders too. I prepared some steel as well, 40 by 40 structural steel. I love these cutting discs. Now let's take these to shape and dimensions. Not bad. Now the holes. I'm going to make a G-code program for it, as I'm going to make 4 of them. Again, some boring counters. Rimming holes for the locating pins. Actually, I bought an adjustable angle block. It's convenient if the angles don't have to be perfect, but there is much work to do on different angles. Nice. I'm always adding loop on pins to make the disassembly more doable. Let's head on to the tool holder holes. I'm going to make these on the lathe to ensure the perfect alignment. Now a drill just a little bit under the size of the finished hole. And now the reamer. It should deliver a nice fit afterwards. to be repeated 3 more times. I would say it's finished. But actually I decided to make one of these holes bigger, just in case of using a bigger tool or tool holder. This one will be 20 mm instead of 16. Quick deburr. And let's get back to the mill. Finally, the holes for the holding screws. And some quick finish passes. I think we are done with these. Let's head on to the guts of the ATC which are left to do. This is going to be the bracket for the sensors inside of the turret. These are inductive sensors. I've got these from HLTNC. Link will be in the description. They will fit perfectly into the 2 large slots I cut out. Something like this. Using the slots, I'm able to adjust the position of the sensors. 2 of them will check the position of the moving spring flange. The third one will be the homing sensor, aka index sensor. It will be recognizing the screw head. Alright, let's wire it up. Be careful when connecting wires here. I used all 5 wires and it wasn't the best idea. Good enough for a DIY. Cable goes here into the cabinet and goes into those over there, and the outputs right there. This power supply supplies energy into the stepper motor. Too much theory is bad for your health. I'm in the middle of preparing the pneumatic unit. For testing, I wired up the solenoid valve. I can trigger it by hand right now, even without electricity. In meantime, I set up some basic settings in CNC. The ATC motor will be the B-axis. The sensors are attached to the port 1 input. and one of them is recognized as the home sensor. We need to home the axis in order to use it. I can open it manually and rotate it using the CNC software driving the motor. Here we can see the sensors are switching when it opens and closes back. The home sensor works too. I type in B with the angle value and it spins. I bond the F6 key to the B-axis homing command. It looks for the home signal and then goes into position using an offset. Here is a quick accuracy proof. 10 rounds and right in the spot. We've got 8 tool positions with 45 degrees in between. Let's do a quick test with 2 tools. This cut-off tool looks really promising. We are cutting steel right here. Let's change to the second tool. Keeping in mind, I'm using manual controls right now. Let's automate it a little bit. I'm going to connect the solenoid to the CNC controller output. To learn making macros, I made my first one for opening and closing the ATC head. If it's closed, it opens it, and the opposite, if it's open, it closes it. I can't resist testing this, please don't blame me. I spent so many hours on it. I want to see how it will work in the future. Honestly, I didn't expect it to work so well with the cut-off tool. I've got to work on parameters though. I did earlier some tries and I was able to get better surface finish. And here is a new connector for the stepper signals. I don't recommend forcing in 2 big wires. Sadly, I had to replace the old one. The terminal for the alarm signal was broken by somebody who was not gentle enough. I decided to wire bare wires to the new one to avoid further damage. And here I went to the most dangerous part of this video. I had to write the homing and tool change macros. What the hell is happening here? Homing macro. Alright. Now the automatic tool change. Let's try. Tool number 2. The stepper motor is a bit undersized. It could be easily a 2 or 3 Nm stepper motor instead of the 1.2 Nm one I have. But it works. Let's add a throttle check valve. The hard couplings hit too hard when closing. That's much more gentle. I think we are done here. In order to mount drills, I bought some C16 to ER20 tool holders, but these are a bit too long. Toys, I mean tools in position. I prepared a quick G-code program. I made it with bare hand. Can't wait to tap the green button and become a real CNC machinist. I made a program pause for lubing. Cutting off the piece requires a lot of lubrication. Judgment? I think it looks not bad for a simple homemade machine. Actually, I made 5 of them. For fun, for science purposes. Repeatable, at least. And so, we've got to the end of the ATC build. That took quite a bit of time. I'm going to share the 3D models and wiring diagrams for UCCNC control as well as the macros with all my patrons soon. Probably when the full ATC build video will be ready. Maybe even sooner. I don't know. Of course, the plans are not perfect. Some of the things were changing as I was progressing with my build. But I was able to build it, so maybe this will help you to get an idea how to start things off. Keep in mind, I'm just a hobby crazy yerba mate midnight garage warrior. Not a specialist by any means. Right now I'm going to dive into the pneumatic tailstock build for this machine. After I spend a lot of time building this thing, I see problems and opportunities I didn't see some time ago when I was designing it. Right now I would like to modify a bit the design and come back to you guys when I will start making it. Pneumatic drive, smooth force adjustment, linear scale extension readout, and so on. That's going to happen soon. Thanks for watching and supporting my work.